compartment, and today's topic is pressure variation in a fluid at rest, or we can say that the hydrostatic law. The statement of the hydrostatic law is the rate of increase of pressure in a vertically downward direction must be equal to specific weight of liquid at that point. For that, we consider a container having liquid and this is the small fluid element having R delta H, and this is the height of fluid element from the free surface of the liquid. This is the pressure which is being acting on the face AB, which is considered CD, ABCD, and this is the small area. You can say that the small area delta A is the small cross section area of the fluid element, and this is the pressure which is being acting on the downward direction. Delta H, this is delta H, and this is delta A. So this is our consideration. What we have considered, this is the small fluid element which is to be considered. Delta H is the height of that fluid element. Small h is the height of fluid element from the free surface. P into delta A is the pressure force which is being acting on the face AB, and P plus del P upon del H into delta H into delta A be the pressure force which is being acting in a vertically upward direction on the face CD of that particular fluid element. So this is the statement. Now consider small p be the pressure acting on face AB, delta A cross sectional area of fluid element, cross sectional area of the fluid element. Delta H is the height of fluid element. Delta H is the height of fluid element. Now small h is the distance of fluid element from the free surface of the liquid. Is it clear? Now these are our assumptions. So again now forces on fluid element. Now what are the various forces which is acting on the fluid element? So first force is pressure force on face AB. So first force of what? This force which is being acting on face AB, E into delta A. Now, pressure force on face CD. What is this? Is the pressure force which is acting on the face CD in vertically upward direction. How much? P plus dt into delta H into del H into delta. Now third, weight of fluid element. Weight of fluid element. Now weight of fluid element is again acting vertically downward direction. And what is the weight? Density into volume. Density into volume. So density of fluid element is nothing but rho into G into volume is del H into del A. This is the volume and this is the density of the fluid element. Now for equilibrium condition, for equilibrium condition, so we can see here, this is the force P into delta A which is acting vertically downward direction on face AB, and this is the force which is being acting vertically upward on face CD, and simultaneously the weight of the fluid element which is again acting vertically downward direction. Therefore, for the equilibrium condition, there are two forces which is acting downward direction, vertically downward direction, and one force which is acting vertically upward direction. Therefore, if we consider the vertically downward direction force is positive and the vertical upward force in negative direction, we can write P into delta A plus rho G delta H delta A minus P plus del P upon del H into delta H into delta A is equals to 0. Therefore, after solving this, P plus delta A plus rho G into delta H into delta A. Now this is minus P into delta A minus delta H into delta H into delta A is equals to 0. Now this positive sign, negative sign cancel. What remains? Rho G del H del A is equal to, this is again negative, इधर चला जाएगा, del P upon del H delta H into delta A. Now this is again common, so this is cancelled. Now what remains? Delta H is equals to, sorry, rho into G is equals to delta H. So this is, again we can write W is equals to del P upon del H. This means that the change in the pressure in the vertical direction is equals to the weight density. This W sign indicates the weight density of the liquid. Now, if we consider this equation number 1, now after integrating equation number 1, what we get? Rho into G. Therefore, again we can write del P is equals to rho G into del H. Therefore, after integration, this is the integration sign.
del P is equals to integration of rho g into del h. Therefore, integration of del P is P, rho into g is common constant term. Therefore, this is h. So this is the equation for the hydrostatic law. Hope